Hornets, thank you for joining me today. Today we're going to be taking a look at how we work with the sum and difference identities of sine, cosine, and tangent. Now I've taken the liberty to write them down and I want you to look at them carefully. You are going to be expected to memorize these 6 formulas. Now be aware we can always work with the tangent as the identities of sine of u plus b divided by cosine of u plus v. This would then give us sine of u cosine v plus cosine of u sine of v divided by cosine u cosine v minus sine u sine v. Now, keep in mind that if you want to work with tangent, you can. If you want to work with the ratio sine over cosine, that's also an option. I didn't mention that today in class, but I do want to mention it now. I personally find that the identities are okay, but they do tend with cosine to give us complex fractions. That means that we have a fraction over a fraction, and we have to get rid of some radicals or issues with rational values, okay, and irrational values. So just be aware. The formula has u plus v, and I've made sure that I have it arranged so that the sine of u comes first, cosine of v plus cosine of u sine of v. Now, if you were watching me today, you'll notice in the proof that I did in class, different from the proof that I did in the video, I had it arranged as cosine and then times sine. This can get a little confusing if you're trying to memorize it. If you keep it in u plus v and therefore u first, you'll find that it's a little bit easier to work with. Same thing with the sine of u minus v and cosine of u plus v. Notice that it's going to have opposites, and cosine uses cosine times cosine minus sine times sine with a plus. Then we have the plus and opposite the minus inside, so cosine u cosine v plus sine u sine v. Tangent will have the sum on the numerator, and we'll have the opposite sign in the denominator, and we have that product, tangent times tangent. When we have a subtraction or a difference, we're going to have a minus in the numerator, and we have a sum in the denominator. Alrighty, let's take a look at the worksheet that we were working on in class today. Now, these are simply some problems to work with so that we get used to the formula. One of the things you have to be aware of is my program does not put parentheses around the thetas. So we are looking at cosine of 2 theta and the cosine of minus 5 theta. Once again, if you want to put the parentheses in, that might help you. And since we have a cosine, we know that we are looking at the cosine of 2 theta, minus means it's a plus, negative 5 theta going behind. If I add these two together, I end up getting the cosine of negative 3 theta, and according to my even-odd identities, cosine being an even identity, I'm going to be dealing with the cosine of 3 theta. That's the answer we're looking for. Taking a look at the formula's identity, working backward so that we can find what it is. Let's take a look at the next one, number 2. Once again, I'm going to put my parentheses in to help me see it clearly. I see that I have a product of cosine minus the product of sine, so I am once again looking at the cosine of negative 4u plus negative 6u. When I add them together, I get the cosine of 10u, and it's a negative. Because cosine is an even function, the negative goes away, and I have simply the cosine of 10u. Let's look at number 3. Notice that we have a sine times cosine minus cosine times sine. Once again, put your parentheses in so that you can see that it's a difference as opposed to something weird. Having a sine cosine minus means that I'm working with the sine, and it's going to be a difference. I'm going to have 5u, and I'm going to have a negative 6u. Notice the double negative is going to make this a positive, and I'm now looking at the sine of 11u. Number 4. Again, I'm going to put parentheses so I can see it clearly. If you find the parentheses are not helpful, then don't go ahead and use them. But if you do, like I do, I would put them in. Notice that we have a tangent with a sum in the numerator. I now know that I'm dealing with the tangent of negative 3u plus a negative 6u. Adding them together gives me the tangent of negative 9u, and because tangent is an odd function, I'm really looking at the negative tangent of 9u. The next one, tangent negative 3x minus the tangent of negative 2x. I can clearly see that it is a difference of tangents. So the tangent of negative 3x minus negative 2x. Double negative applies, and when I add, I end up getting the tangent of negative x. Because tangent is an odd function, the negative comes out, and it is the negative tangent of x. Number 6. Once again, put the parentheses in so that you can see what it is. This is a sine cosine plus cosine sine, so we know we're dealing with the sum of a sine function. Sine of negative 2x plus negative 5x. Adding them together gives me the sine of negative 7x. The fact, because cosine is an odd function, the negative will come out, and I have the sine of positive 7x. Number 7, cosine. Cosine plus sine sine. I know that I'm dealing with a cosine of a difference, minus 6x minus negative 3x. The double negative will apply, and I'm looking at the cosine of negative 3x. Because cosine is an even function, the negative drops away, and I have the cosine of 3x as my answer. Number 8, cosine cosine plus sine sine. We know we have a cosine difference. So cosine 3u minus negative 2u. This is going to give me a double negative, and I now have the cosine of 5u. In the second part that we are asked to do, they want us to verify the identity. They want us to go through it and show that we are indeed going to get a 1 minus tangent theta and a 1 plus tangent theta. According to my identity, I know that I'm going to work with the tangent of pi over 4 minus the tangent of theta divided by 1 plus tangent pi over 4 tangent theta. Now we know that tangent of pi over 4 is 1 from our ratios, and so I'm looking at 1 minus tangent of theta divided by 1 plus, once again, tangent of theta. And I have verified the identity. Number 10, same concept, same process, not much is different. We're looking therefore at the tangent of 3 pi over 4 plus the tangent of theta divided by 1 minus tangent of 3 pi over 4 times the tangent of theta. Now we know that the tangent of 3 pi over 4 is negative 1. So I have negative 1 plus the tangent of theta, and I'm dividing by. Now because I get a negative 1 here, I end up with a double negative, and it makes it a plus tangent of theta. I have proven my identity, verified my identity. Let's go to the next one. Cosine. We have a sum. So we're going to write it as the cosine of theta times the cosine of 180 degrees. We then have the minus sine of theta. sine of 180 degrees. But we know that the sine of 180 degrees is negative, and we know that the cosine of 180 degrees is negative 1. Substitution gives me negative cosine of theta minus 0, and I have verified the identity. 12. We're dealing with a sign with a negative, or with a minus. So I'm going to be doing that difference formula. Sine of theta, cosine of 270 degrees. We have a minus, and then I have the cosine of theta, and then I have the sine of 270. Now we know that the cosine of 270 is 0 degrees, and the entire first term product is gone. It's multiplied by 0 and it disappears. Since the sine of 270 is negative 1, I'm looking at a positive cosine of theta caused by that double negative. And I now have proven the identity, or at least verified it. 13. Now we're going to be finding our exact value by working backward. We know this is a tangent of a difference, so I have the tangent of 5 pi over 9 minus 2 pi over 9. This is giving me the tangent of 3 pi over 9. This is the tangent of pi over 3. And we know that the tangent of pi over 3 is root 3. Therefore, that is my answer. Notice it's an exact value. Cosine, cosine minus sine, sine. We know we are dealing with the sum of a cosine. So I have 11 pi 18ths. I'm going to be adding 2 pi 18ths, and I'm going to need to get a common denominator. That's 18ths. So I have 18ths, 11 pi plus, that's a 9, Mr. Lamb. Multiplying it by 2, I have 4 pi. This is giving me the cosine of 15 pi 18ths, which will reduce to the cosine. I'm going to take away the 3, 5 pi over 6. And we know that the cosine of 5 pi over 6 is negative root 3 over 2. Notice if you don't know your ratios, this is going to be pretty difficult. Number 15. Cosine, cosine plus sine, sine is a difference of cosine values. So cosine of 17 pi 18ths minus 7 pi 36ths. I get the common denominator by multiplying the top and the bottom by 2. So the cosine of 34 pi minus 7 pi 36ths. This is going to give me 27 pi. So the cosine, 27 pi in the numerator, divided by 36, can now be reduced by factoring out the 9. This will leave me with the cosine of 3 pi over 4. This is in the second quadrant. It is a negative ratio, and I end up with negative root 2 over 2, an exact value. Number 16. Once again, I have a tangent minus tangent in the numerator. Therefore, I'm looking at a tangent with a difference. I have 2 pi over 9 minus pi over 18. Getting the common denominator, I have the tangent of 4 pi minus pi 18ths. Simplifying, I get the tangent of 3 pi 18ths. I reduce for the tangent of pi over 6, and I know that the tangent of pi over 6 in the first quadrant is root 3 over 3. And that's my answer. Now, when we get to the last 4 questions, we actively have to stop and think, what is going to make negative pi over 12? Always keep in mind you want to be able to reduce. So I want to make sure that whatever I break that pi into, or those the two things that I'm going to be subtracting, have to be simplified and therefore are multiples or have a factors within the 12. That means that I'm talking about a larger value, such as pi over 3, minus pi over 4. Notice when I get the common denominator, I'm looking at 4 pi over 12 minus 3 pi over 12. Do you see how that turned out to be a positive? So I want to flip it. Always double check. Now, once I know what I'm working with, I'm now going to use my identity. So we're going to have pi over 4 minus pi over 3, so that we're subtracting the larger value to get the negative. We're now going to go ahead and go to our formula. Here we go. Tangent of pi over 4 minus the tangent of pi over 3 divided by 1 plus tangent of pi over 4 times the tangent of pi over 3. We now have to replace our values. We know the tangent of pi over 4 is 1. We know the tangent of pi over 3 is root 3. Denominator. We have 1 plus 1 times root 3. Notice, we have a radical in the denominator, and we are forced to multiply by our conjugate pair. 1 minus, used a plus there, 1 minus root 3. 1 minus root 3. This is giving me, now I have to FOIL. So think about it, FOILing. The denominator is easy. It's 1 minus 3. But look at this numerator. I have a 1. I have a negative negative, which is plus 3. I have a minus root 3, a minus root 3, which is giving me minus 2 root 3. I'm now going to simplify it, since I have 4 over negative 2 minus 2 root 3 over negative 2, and I get negative 2 plus root 3. That's my answer. Let's go ahead and take a look at number 18. Now we're trying to add two numbers. 2 and 3 are factors of 12, and 2 plus 3 add up to 5. There you go. Tangent of 2 pi over 2 pi over 12, and I have plus 3 pi over 12. I'm going to simplify this so that I have the tangent of pi over 6 plus the pi over 4. Now I go to my formula. Putting it into the formula, we have tangent of pi over 6 plus tangent of pi over 4 divided by 1 minus tangent of pi over 6 tangent of pi over 4. Now we know that the tangent of pi over 4 is 1. We know the tangent of pi over 6 is root 3 over 3. So we're going to replace it entirely and go to the denominator. Since our tangent of pi over 4 is 1, I'm just looking at 1 minus root 3 over 3. Now we're going to have to do a little work here. We've got to get the common denominator and take the reciprocal. So I'm looking at root 3 plus 3 over 3 divided by 3 minus root 3 over 3. This gives me root 3 plus 3 over 3 times 3 over 3 minus root 3. I'm going to have to multiply by the conjugate pair afterward. So I have root 3 plus 3 over 3 minus root 3, and I'm going to multiply by the conjugate pair in the denominator. Make sure you can see that as it's starting to bunch up. I'm going to multiply by 3 plus root 3, 3 plus root 3. We go to a separate page so that we can continue with this. As I continue, you'll notice as I FOIL, I've got 3 root 3, I have a 3 root 3, and I have a 9 plus 3. The denominator is now 9 minus 3. See how I have a 9 and the root 3 and negative 3 root 3 cancel. Now what I have to do next is simplify. I can clearly see that I have a 12 plus 6 root 3. The denominator is 6, and I distribute the 6 to both. I end up with 2 plus root 3, and there's my answer. Now we're going to do that again with number 19. So let's look at our cosine of 11 pi over 12. And I'm going to do it on a separate piece of paper so that I have enough room. Once again, I need to figure out what two values can be added. Well, let's see. 8 plus 3, 8 and 3 can reduce with the 12, and 8 plus 3 makes 11. So I'm going to call it cosine of 8 pi over 12 plus 3 pi over 12. Simplifying it gives me the cosine, and I then have 4 pi over 3 when I reduce. Let's change that again. Hang on a minute. That's 2 pi over 3. See how I brought out the 4? I'm factoring out the 4. I don't want that up top. That's a 2. Then I have, reducing this, is pi over 4. We're now doing the sum of a cosine. So I am looking at the cosine of 2 pi over 3, cosine of pi over 4, minus... Yeah, this is Ithaburn in the office. Can I have a custodian go to Pat in the gym? Sorry about pausing there. Mr. Ithaburn had a announcement, and that wasn't necessary for us to hear. So I'm looking at the sine of 2 pi over 3, and then I have the sine of pi over 4. We're now doing a replacement with our ratios. So the cosine of 2 pi over 3 is negative 1/2 times the cosine of pi over 4, which is root 2 over 2, minus the sine of 2 pi over 3 is a positive root 3 over 2, times the sine of pi over 4, which is root 2 over 2. Notice I now end up with negative root 2 minus root 6 all over 4. And that's my answer. Notice it's an exact value. Our last one that we have here is sine of 7 pi over 12. So we have the sine of 7 pi over 12. And we have to think about, what are we going to do? Are we going to add, or are we going to subtract? Well, I'm going to go ahead and I'm going to add. Now, if you decided to find the values that we can subtract with, you will still get the exact same answer, as long as it's correct. So I'm looking at 4 pi over 12, and I'm trying to add 3 pi over 12. See how that gives me 7 pi over 12? Reducing it, I have pi over 3 plus pi over 4. Using my identity, I'm now going to have the sine of pi over 3, cosine of pi over 4, and then I have a plus cosine of pi over 3, sine of pi over 4. We now plug in, what is the sine of pi over 3? Root 3 over 2. What is the cosine of pi over 4? Root 2 over 2. What is the cosine of pi over 3? 1/2. What is the sine of pi over 4? Root 2 over 2. Notice, if you don't know your identities, this really gets hard, because you won't know what to substitute with, and you won't be able to multiply. I end up with root 6 plus root 2 over 4. And there is my answer. Now tomorrow we're going to be doing quite a bit of these as we break them down, we substitute, and we work with these formulas. I hope this has helped you to understand what I was trying to get at. Please remember, you must memorize these 6 formulas. If you do not, I will not give them to you on the test, and that may cause a problem for you, and I don't want that. I believe that you can succeed. I believe that you can do this. I know it. So please prove me right and study. Thank you very much, Hornets. I hope this has helped and was useful. If you liked it, please remember to click like. If you have concerns or you felt that there was a problem, please remember to let me know, and I will try my best to improve. Thank you very much. Have a good evening. Cheers.